Hello, everyone. My name is Artemis Scarlatidou, and I am lecturer in citizen science in the Department of Geography at UCL. Welcome to the series of online webinars that we organize at UCL and the People Nature Lab at UCL East, and which are funded by the Erasmus Plus project called Community-Driven Digital Action, a Catalyst for Social Change in the COVID-19 Crisis. I'm going to copy the link in the chat area of the project if you want to find out more. So the online webinars aim to promote citizen science, hence their title, Citizen Science for All Talks. Each Citizen Science for All event has a specific theme where we invite world-leading experts to share their knowledge from their specific field of practice and the many years of experience they have working in this area. In this Citizen Science for All event, we will be talking about how citizen science is used to tackle noise pollution. Citizen science is used to address several challenges, one of which is noise pollution, which is of course a serious problem related to health problems, such as lack of sleep, psychological issues, and negative social effects, such as, for example, weakness of social cohesion, and so on. Noise pollution is an urgent problem in many urban areas, and there are many active community groups and individuals who are on the lookout for a solution to help improve their living conditions. Today we have two speakers to talk with them about noise pollution and citizen science. Dr. Antonella Radicchi is the principal investigator of the HEIDI Project and the owner of the HEIDI app. She's a high-level expert for the European Commission Directorate General Research and Innovation in the mutual learning exercise on citizen science initiatives, policy, and practice. Antonella's work is inspired by a humanist perspective on knowledge for urban design and planning, and it is driven by a vision of moving towards more livable, inclusive, and zero-pollution cities. Antonella is a licensed architect and holds a PhD in urban design and territorial planning with over 10 years of professional experience in Germany, Italy, and the US, leading research, teaching, and practice-based projects in the higher education and architecture industry. Domains of expertise include urban design and planning, livability and the senses, citizen science, mobile apps, and creative research methods. Our second speaker is Dr. Nold. Christian is a lecturer in design at the Open University. He's an academic researcher, designer, and artist, inventing and analyzing new models and technologies for collective representation. In the last decades, he created large-scale public art and design projects, such as the widely acclaimed biomapping, emotion mapping, and Bilmer Eura, I hope I pronounced that correctly, Christian, which have staged with thousands of participants across 16 countries. He previously has been a research fellow at the Social Design Institute and the Extreme Citizen Science Group here at UCL, where he coordinated and evaluated the Horizon 2020 Doing It Together science project. Christian has written numerous books and journal papers, including the widely cited Emotional Cartography Technologies of the Self. During the event, Ali Shepard will be live tweeting it, and you can use Twitter to post your questions, or you can use the chat area here to post your questions, and Ali will transfer them on Twitter too. We might be able to take one or two questions at the end, depending on the time, but our speakers are happy to answer your questions on Twitter, so you can talk to them later on there. So thank you very much. Antonella, over to you.
Thanks a lot for this kind invitation. It's a great pleasure to be here today. So I'm going to share my slides with you. Hope you can see them. So thanks a lot also for this kind introduction. So I'm Antonella, and today we'll talk about citizen science for contextualized quiet areas policies, drawing on examples drawn from the deployment of the HEIDI project in Berlin. So as Artemis has anticipated, my work is inspired by the humanist perspective on knowledge for planning and urban design. And specifically, I use citizen science for enabling the participation of people in environmental assessment and planning processes. In my talk today, I would like to make two arguments. I would like to first invite you to make a mind shift. So we will think of noise as a resource, and specifically we will think of quiet areas as a kind of sonic resources. In fact, literature shows that access to quiet has huge beneficial impact on our health and well-being, and it also brings to our society monetary and non-monetary benefits. And for these reasons, it's very important to protect, to identify them, especially in cities, in agglomeration, and to protect them so that possibly everyone has access to them. The second point I would like to develop through my talk is that the potential of citizen science to inform a public policy, and specifically the potential of citizen science to challenge the view that policymakers have of quietness, and the potential of citizen science to point to alternative criteria for the urban quiet areas. So we have a regulatory framework that deals with and protection of quiet areas at the European level. We have in fact the Environmental Noise Directive that mandates every member states to identify quiet areas in open country and in agglomeration in order to protect them. The end also offers policymakers a definition of quiet area that they can use to identify them. So this definition is merely based on noise levels that can be set up by every member state. So the importance of protecting quiet areas is also highlighted by the World Health Organization in the latest report about environmental noise that was released in 2018. However, how to identify quiet areas in cities and what is quietness for people are really still open questions, because we really have not yet found an appropriate method that could be applied everywhere. This was highlighted by scholars who criticized the definition provided by of quiet areas provided by the Environmental Noise Directive. And again, scholars pointed to the limitation of a definition that is only based on noise levels, on quantitative criteria. In fact, they highlight that sound is, of course, an objective phenomenon, but it's also a subjective phenomenon. And the way we perceive sound is hugely influenced by our cultural, social, and political factors. Think, for example, of what happened at the beginning of the past century. The Scientific American Journal welcomed trams and automobiles as harbingers of a new age of urban tranquility, whereas today noise from traffic is the second most environmental stressor, only after air pollution. So to contribute to this line of research and to contribute to address these open questions, I came up with this framework, with the HEIDI framework, that is a participatory framework for enabling people participating, mapping, assessing, and planning quiet areas in cities. The framework grounds on two methods, the HEIDI mobile app and sound walks. The HEIDI mobile app allows you to go to your favorite quiet area, map it, and collect mixed data about the quiet area. You can collect audio recordings, take noise level measurements, take pictures of the quiet area, and also provide your subjective responses to the assessing the environmental quality of the quiet area where you are by answering questions that are embedded in the app. And then you can even share the data you have collected, and they are linked in real time to an open access web map that is available at this web link. You can also use the app within the context of sound walks that you can guide with a group of people along predefined routes that crosses quiet areas. Then you stop at the quiet areas and you ask the participants in the sound walks to use the app to map and assess the quiet areas where you are. And again, the data collected will be immediately shared and made available online. So let's have a look now at the deployment of the HEIDI framework in Berlin and discuss the results and the impact that this application has had on policy making. So at the time of the case study, the Berlin municipality had in place a plan of quiet areas that they created previously in 2013. And this plan identified two kinds of quiet areas represented here in dark and light green. So the municipality used quantitative criteria like noise levels, sites, and land use to identify quiet areas like huge forests in the surroundings of the city and parks sparse in the city center bigger than 30 hectares. In 2018, when we started working with the municipality for using the HEIDI framework, the municipality was in the process of updating the plan of quiet areas in response to the environmental noise directive, and they wanted to use citizen science as a method for involving the public and collect more data about new quiet areas that the public, that the citizens value in their neighborhood. So we promoted a bit the app at the city scale, and also we ran a couple of sound walks in selected neighborhoods. As a result, the citizens mapped 174 quiet areas, out of which 159 did not overlap with the quiet areas that previously were identified by the Berlin municipality. Here on the right side of the slide, you can see the data cross-sourced with the HEIDI highlighted in red against the map of the Berlin plan of quiet areas. Another interesting result that emerged from the analysis of the data collected by citizens was that these kind of quiet areas, as you can see here from looking at some of the images of these new quiet areas cross-sourced by people with HEIDI. So what was striking is that these areas included small urban squares, alleys, small streets. In other words, paved places that challenged the idea that urban quiet areas mainly coincide with green spaces, big parks, or natural forests. Space-wise, another characteristic that emerged from the analysis of the data that people collected using HEIDI is about the typology of these quiet areas. We have found out three typologies: linear paths, like paths along water infrastructures, but also open areas, as I said, like urban squares, and also enclosed nooks like, for example, secret gardens or even publicly accessible courtyards. Comfort-wise, people associated positive emotions to their experience they had in the quiet areas that they mapped using HEIDI. Most of the feelings reported were positive, and people reported the sensation of feeling calmness, interest, pleasureness, comfort, happiness, fun. And some of them also reported negative feelings, especially when the quiet areas were not so much perceived as being completely quiet, but there were some factors affecting this perception of quietness, like the visual quality of the places or some sort of background noise. I'll give you a quick example. You can have a parking lot that is very quiet, but at the same time, you don't have any place where you can sit to experience this quietness. And in the end, you find this place quite boring because it's not attractive. There is nothing, there is not so much to do. It's not so beautiful from an aesthetic perspective. So quietness, it's a multi-dimension quality of the urban environment that is defined by several criteria, not only by the sonic quality of the urban places. In terms of sounds that people associated with the quiet areas, we had positive and negative sounds that people indicated as being positive and negative for their perception of quietness. Sounds like bird sounds or natural sounds coming from water and from the wind through the leaf were of course rated as positive for the perception of quietness. And of course, not surprisingly, sounds coming from traffic were rated as negative for the perception of quietness. What I would like to highlight here is that we have controversial results when it came to assessing human-made sounds like human voices and human movements like footsteps. In fact, it was particularly challenging for people to agree on finding, for example, human voices as positive for their perception of quietness. For some of them, human voices were an important factor in the quiet areas. For others were negative, especially when they perceived these voices as too much loud or too much invasive. So I'm going to wrap up my presentation, and I would like to highlight some points, some lesson learned from this case study. So number one, through the data collected by citizens using HEIDI, we were able to provide evidence towards the limitation of the physical measurement criteria used for defining quiet areas by the Berlin administration. So people, by collecting the data, were able to point to perceptual qualities that were important for them in the quiet areas, and also citizens highlighted that there is the possibility to identify quiet areas on the neighborhood scale.
Stop. Hello.
Hello?
We are just being Zoom bombed.
Sorry, I just removed whoever was this person.
I wanted to participate, so
yeah,
not a problem at all. No, not at all. And and the findings also pointed to the added value of using citizen science methods for identifying new and existing quiet areas that could be introduced and have been introduced in the new plan of quiet areas that was released by the municipality of Berlin in 2009. was published in 2020, and it covers the 5 years until 2023. So not only the data collected by people were included in the policy document, but also the municipality decided to add a new kind of quiet areas that they termed as the urban quiet and relaxation areas. And these new kind of quiet areas has some of the characteristics that have the quiet areas identified by the citizens using HEIDI. So they are mainly smaller quiet areas embedded on the neighborhood level, not necessarily green areas, but certainly areas with a high environmental quality, sonic and high sonic quality, but also an overall environmental quality, high environmental quality. So if you're interested in reading more about this case study and about best practices for environmental noise monitoring, you can have a look at these 3 open access references. One is the Geographic Citizen Science Design book, edited by Artemis and Muki. And then we have 2 reports, one published by the European Commission about best practices in citizen science for environmental monitoring. And the last one is the report made by the GRC about citizen-generated data for public policy. So thanks again a lot for listening, and I'm happy to answer your questions later on, or you can even drop me a line at this email address or via Twitter. Thanks a lot, and over to Christian now.
Fantastic, Antonella. Thank you so much for that very inspiring talk. Christian, over to you.
Super. I was just going to say, Antonella, if you have to go, you could take some questions now if there's some pressing ones right now.
There was one that was asking about whether the app is available to other parts of the world, which I hopefully answered correctly, but you might want to say a few more things, Antonella.
Thanks a lot. Yes, I didn't mention this, but the app is still available. It's of course free and is available in 5 languages: Italian, Spanish, Portuguese, and English, of course. And it's currently used internationally. So it started in Berlin as a case study, and then for some reason scaled up internationally. And we have also a very nice bunch of ambassadors, some of them there in the UK. I would like to mention in Bristol, we have several important ambassadors, but also in other cities in Singapore, in the US, in Brazil. So everyone is welcome to use the app, and if you have any questions, you can reach out to me. Also, maybe important to say, if you want to use the app, if you want to explore the data, they are online, but you can also reach out to me, and we can also share the data sets in a more structured way.
Brilliant, thank you. Alice, are there any other questions for Antonella on Twitter?
No, I haven't had any. Let me double and triple check. No, there aren't.
Okay, then.
But I can stay until the end, so if other questions will pop up, I will be here.
Super. Hello, can you see my screen properly, full screen? Super.
Yes.
So yeah, thanks very much. Thanks, Antonella. That was great. Yeah, my name is Christian Nold. I'm gonna, hang on, let me start my timer so I don't run over. I'm gonna talk about citizen science for controversies, and this is me. Yeah, as kind of Artemis introduced, I was in the extreme citizen science group, and my PhD was a sort of social science ethnography of citizen science. So that might explain a little bit where I'm coming from in terms of this talk. And now I'm a lecturer in design, so I'm interested in sort of the design aspects of citizen science. So noise, I guess in terms of the way that most people encounter noise mapping these days is in terms of modeled noise mapping. So this is the sort of typical image you have, and it's often modeling traffic noise. So you see here the kind of bright red is kind of the modeled dispersal of noise, basically. And often it's done on a single source. So, you know, who knows if there's other kind of sources that are just not part of the traffic noise. And as Antonella already mentioned, there's this EU noise directive, which calls for these strategic noise maps to be made. So there's a real incentive, and has been for the last, well, I guess almost 20 years now, to kind of produce these kind of local maps of cities in terms of their noise. And I guess one of the key drivers in this whole thing is also the smartphone sort of imager, microphone, wireless sensor packages that we all carry in our belts and our pockets, as this kind of little quote says. And I think that's really, you know, that citizen science is really trying to jump on the bandwagon of these kind of devices that exist now. And often the assumption is that citizens plus smartphone are basically a cheap way of gathering lots of noise data, with a sort of very basic assumption that more data equals better science. And then you go and get these kind of odd headlines like how 2 billion smartphone users can save species, right? There's a sort of conflation between the sort of number of data points and the sort of the impact you might have. And I guess the issue is that I think a lot of the noise mapping actually occurs in relation to controversies and requires specific methods and instruments and setting specific objectives, which are not about quantity of data, and you might need to create specific citizen science devices in order to do that. So this is what I'm going to try and talk about today, to try and illustrate to you what it might mean to design for controversies in terms of citizen science. Okay, so controversy, a definition. So it's a prolonged public disagreement or heated discussion. And what's, I think, interesting about that is this idea of a prolonged public disagreement. So these things are not sort of momentary things, they hang around, and they're all also often about something. So that example that's given in the definition is, it's the design of the building that caused the controversy. So controversies are specifically about something that exists in the world that lots of people care about, and that's what the public disagreement is about. So just to show you a few controversies that are not noise related per se, let's say the mad cow disease that people might remember here in the UK, where there was a worry about this beef which might cause Creutzfeldt-Jakob's disease, for example, and there was lots of controversy about whether it was safe to eat this particular beef. So these things appear and they disappear. But fracking in the UK, for example, is something that's often talked about in terms of ground water pollution, for example, but also noise might be another contributory factor to this whole thing. So often controversies involve multiple ways or multiple problematics, if you like, that are kind of complicated. So the particular problematic I'm going to talk to you about is Heathrow Airport, which is the sort of case study I want to try and talk through to give you a sense on how citizen science works differently when you do it inside controversy contexts. So Heathrow Airport, this blob at the top, is the planned third runway at Heathrow in the moment. So if this third runway gets built, basically that whole area, that village there, would be obliterated, which would cause a huge amount of noise, increased air pollution, and all sorts of complicated factors. So the controversy is really about whether this third runway should be built. The way it's often talked about is in terms of, you know, oh, hello.
Oh, sorry.
That's all right, all right.
Apparently someone else got unmuted.
That's all right, sounds more exciting.
Yeah, I mean, if people get accidents, sadly, we had already someone who was not part of the session, so please just make sure not to intervene in the session, or we will have to take you out of it. So yeah, just a warning.
Yep. No noise pollution from guests.
Indeed, indeed. So the controversy is often kind of framed as a lot of residents here, for example, opposing this third runway being built, you know, here organizing this giant no to the third runway, or here a yes to Heathrow expansion. So there's an interesting visual language being built here to talk about this controversy. You know, these small little red aeroplanes that you also see at a political level being used like this. So the question is, how does citizen science really deal with something as complicated as Heathrow Airport and the kind of controversy of that? And this was something that I was involved at while I was at the Extreme Citizen Science Group. And we were introducing one of these smartphone apps into the context. And I think we realized quite quickly that we did not understand the whole complexity of the context. And we started running into problems really. And I guess I want to tell you the story of a little bit of the complexity of Heathrow. And the whole thing of Heathrow really revolves around these noise contour lines. So when people see these, they think that this is actually just noise dispersal, but actually what they are is that they're based on social science interviews that basically researchers visited people's homes and asked them, wow, that was fun, at which noise level they were disturbed. This is based on various kind of research. So this is the Schultz curve, which kind of basically found out that particular noise level causes community reaction, i.e. protest. So you see as the decibel at the bottom goes up, people's level of legal action, complaints towards vigorous community action starts to increase. And what they started doing is that they started plotting a kind of curve between this. So you see these very distinct dots on this particular curve. So what you actually have, these contour lines, they're actually estimates of resident protests. These are not just noise dispersal at all. So these are not, this is not just decibel, this is these particular lines. So like 57 decibel dBA, L10 is considered to be the onset of noise disturbance where anybody who lives within that area is going to be causing protest. So it's really interesting that these contours are basically used to make the decision about building this third runway. So how this extends and how many people are within these contours is really what it's about. So these things are not really talked about within citizen science. These are complicated historical things that are very highly technical. They involve huge amounts of manuals, documents. I had to interview a lot of experts on aircraft noise. These are very specific to Heathrow, and they're engaged with the whole dynamic of what's going on there. So here you see one of the residents, for example, who talks about this particular 57 dB noise threshold. That the reality, of course, is that noise continues to be hugely disturbing to many people considerably below that threshold. So these noise contours are highly political and really are fundamental in kind of the way the controversy works. And yet these noise metrics are actually kind of more a matter of convenience, according to the sort of the technical experts on this. So these things are actually there to be redesigned. So in the 70s, for example, they stopped doing this self-reporting and moved over towards these kind of contours. But there's actually a possibility to bring them back. So for me, this was really an opportunity to think slightly differently about the sort of citizen science approach needed. So the kind of devices that I built were propositions. They were designed to be not necessarily solutions. They were not doing noise monitoring in a very straightforward way, but they were designed to work with a controversy. So this was, for example, a little prototype I built that was used in workshops with local residents, where this particular object was speaking on behalf of the local residents. So as an aircraft flew over, the spoken or the text on this little device, which was measuring the noise level, was kind of changing from calm towards painful, almost speaking on behalf of the local residents. And of course, this kind of annoyed the participants because it was doing something very similar to the way these metrics are speaking on their behalf. So this actually small prototype was really started the whole discussion about the need to develop other kinds of metrics and other ways of talking about the experience that the residents are feeling that are not kind of encapsulated by little devices like that speak on their behalf. Or another particular one like this that would be fitted outside people's houses and would measure the noise level in real time and would flash as a certain noise level was exceeded. And this prototype really divided the group because they didn't want to have it on their house. because they were nervous about being seen as kind of NIMBY troublemakers or activists, but they thought it should be mounted on public buildings. And actually it started a really interesting discussion about, you know, are the public institutions, for example, are they working with Heathrow Airport or not? Or this particular one, which actually just sends a text message whenever a particular noise level was exceeded that local area. So that the whole thing became about whose mobile phone number should be in this device, who should be texted every time a plane flew over. And it became a question, you know, who's responsible? And it really was for developing the group. So this was citizen science for developing the group and their particular strategic objectives. This was not just about measuring a noise to put it into a database. That was one of the prototypes, just turning noise into numbers. This was going into a database, and of course this was liked. But the device I built was basically doing this quantification of noise, was also doing broadcasts. So the device basically created, here it is set up in somebody's back garden. The residents I worked with set up this device, and it produced kind of highly accurate numbers from this very highly calibrated measurement microphone. And it allowed them to make targeted noise complaints about particular out-of-hour flights, like this particular British Airways flight. So these were actually official complaints made by residents using this device. But it also allowed you to look at a huge amount of data over time. So the residents never had their own data sets before. So now this particular resident had 14 million data points from their house. So this was not model data, this was actual measured data. And they could make arguments about, they could contest arguments that, for example, Heathrow noise was getting quieter. Well, it certainly wasn't getting quieter at this person's house. But at the same time, it allowed people to listen to the sound in real time. So these speakers that were set up in various gallery exhibitions, you could listen to the same plane from multiple locations. So the speaker on the left might be, was from one microphone that was in West London, and the other one was in South London. And you would sometimes hear the same plane, but actually from really different locations. You could really get a sense of what this thing felt like in people's lived experience. It wasn't just these kind of abstract numbers. But it was something experiential, and it really allowed a different audience to engage with the problem of noise and the controversy of noise. So the main observation I guess I want to make from this case study is that controversies have no clear boundaries, and they involve lots of heterogeneous elements. So they involve people and material things, so these might be objects, sensing devices, but they also involve cultural dynamics. They have a history, right? These are much more complicated than the sort of way in which citizen science often frames the kind of locations that they enter. And I guess the key thing is that this particular case study used methods that were beyond sort of classic citizen science methods. It involved a lot of historical and technical research into the controversy at Heathrow. There was a long-term ethnography with communities, experts, and stakeholders. I mean, in some ways, I've been involved there for, I think, about 9 years on and off. Basically, I was involved with Heathrow. So this is something, this is a very long-term engagement with a place, much more so than the way a lot of the kind of smartphone apps engage with noise at a particular place. And as a result of this project, there was a sort of controversy-specific instrument design. You know, this device that I built, this kind of box here, whoops, came really out of the problem of Heathrow, and it was developed for that context. So the idea of building specific devices for particular controversies, I think, is very interesting to think about. So that was methods. And I guess the argument I'm also making is that there's different objectives involved in there. This is not data gathering which is used to support multiple actors in relation to the controversy. It's not just for researchers who might want to get a large data set. The individual who actually were hosting the devices wanted to have the data sets. The pressure group I was working with wanted the data set. The local councils wanted to be part of this. and even the airport themselves. So there were really multiple actors that were interested in this data gathering in different ways. And I think that's really interesting to think about in terms of how citizen science needs to work in terms of the objectives. And I guess my argument is also that data gathering creates a controversy relevant epistemic object. So, you know, the app I showed you right at the beginning, the Wide Noise app, they were trying to use a grid square protocol, the idea that people were supposed to go out any time of the day and night to collect noise samples. Well, actually that was not relevant because there was no sense for people to wake up at 4 in the morning because there were no planes that are allowed to fly. So people did not want to go out and take measurements really far from their home in the middle of the night, when actually the location of the planes and when they were flying was really known. But what was not known is the actual specific impact and the specific situated impact of that in their homes, for example. So one of the questions is, you know, do you do noise recordings inside people's homes? So there's a sort of the way with Wide Noise, the sort of the epistemic logic, the data gathering was being done was not suitable for the controversy of Heathrow. So my suggestion is that doing data gathering that really makes sense for a particular controversy, I think, is something that could really be introduced to citizen science. So I have this kind of final kind of diagram just to kind of try and make that argument, is that in citizen science, there's often this idea of a generic research site. Cities, there's no particular distinction being made as to where this is taking place or what's the uniqueness of this site. Whereas I think when you think in terms of controversies, you think about the complexity historically and socially of that place. And often citizen science addresses individual citizens, whereas I think if you think in terms of controversies, issue publics emerge, people who care about the issue at stake, like the local pressure group, for example. Again, this idea of universal instruments versus controversy-specific instrument design. And I guess one of the key things is that in citizen science, often in the literature, the discussion is really about quantity of data, whereas actually my argument is really about relevance of data. And I think there's a real distinction between them. But also this idea of singular knowledge and multiple knowledges. So the idea, is it just for the scientists or researchers, or are there multiple kinds of knowledges being addressed here of the different groups? And ultimately, who's the beneficiary of this kind of research? Is it just the researchers, or is there a multitude of beneficiaries? And I guess I argue is that controversies impel researchers to really think about the different benefits and different actors that can benefit from these kind of activities, because they're social activities, they're done with people, they're about something that people care about, and that actually change areas. As Antonella was saying, they can feed into policy making, but they can also feed into the way that people do their daily lives. So I think citizen science has to really think about these multiple beneficiaries from their activities. So yeah, that's my pitch, that there's maybe a slightly different kind of citizen science needs to be done. And I'll leave it there. Thank you.
Thank you very much, Antonella and Christian.